All right, it's Friday today, in case we weren't keeping track of the days. So, looking forward to this weekend. So Fridays, generally, we will not cover any new material. Here, we'll review what we've been doing. Two things we'll generally look at. One is we'll look at some of the practice problems and working on those. And then the other one is we'll take a peek at the assignment and see if you need any help getting started on the assignment, particularly these first couple weeks when you're still getting used to, kind of this environment. I think it's helpful to kind of get started on the assignment and walk you through it a little bit more. Later on, I think it's easier for you to understand them after you've done a number of assignments, but we'll talk about that. We certainly won't do it in class, but again, we'll try to get you started so you can work on that. So again, things are due on on either Sunday or Monday for this class. So again, Wednesday we did the learning activity, and hopefully you posted something to discussions. Remember, you've got to you're creating some ASCII art from a picture, and you want to post your example, but you also want to comment on two other people's posts or post your favorite example. So I want to see from everyone 3 posts, their original posts with their own art, and then 2 replies, either saying, boy, this Pokemon looks really cool. I always love seeing Charizard in ASCII art or something like that. Or if you want to just Google and find your favorite ASCII art out there, you can post that also as a reply to someone else's, or I guess that would be an original post. That would be fine. So 3 posts from each person to the discussion areas. The other thing we're going to look at then later on today is the assignment. And again, I'm in about half an hour. I'll kind of walk you through that. But before that, I want to try to look at some of these practice problems. So I'm going to go to the practice problems. And again, this is just a sheet with lots of tabs over here on different practice problems. They tend to get harder the further to the left they get here. So like this first one is just a clothing picker. You ask the user to enter today's temperature here. So they might say it is, what is outside, 72 degrees outside today. And then your computer will look at that. And if the temperature is less than 50 degrees, I'll recommend they wear a light jacket or a sweater. Otherwise, if it's above more than 50 degrees, you said they don't need a sweater or jacket. Because I'm a parent, and as a parent, I find that every youth need help because you're not able to decide by yourself if you should wear a jacket or not, right? That's way too complicated for youth to decide. So we're going to write a program to do that. Now, you can do, if you're from the US, you probably want to do the whole thing in Fahrenheit, which is what we're used to doing. Again, if you're from somewhere and you're used to Celsius, do the whole thing as Celsius. That's fine. Also, whenever I spend a couple months in a country that uses metric, it always just takes me a while to get used to that Celsius measurement. Yeah, do this in either Fahrenheit or Celsius, but just pick one or the other for this, and just tell the user to enter the temperature in Fahrenheit or Celsius, whatever one you're going to do for this. So, I mean, that would be a nice simple one. It just has one if-then statement, 2 print statements. The whole thing is probably, 5-6 lines of code there. So you should be able to do something like that there. Now, some of these get more complicated here. So like here is the Northern Lights one. I don't know if you've been watching the Northern Lights at all over last year, but we're in the peak sunspot cycle. It's a 11-year cycle, 7-year cycle, 11. I don't know what the cycle is, but we're in peak sunspot weather, which means we get lots of Northern Lights. This was from last spring, just north of Duluth. on one of the nights when the Northern Lights were out. I remember driving out there with my wife and daughter. We thought, oh, we're just gonna drive out of town and go find an empty spot. Because we knew the Northern Lights were out that night, and we drove out there. There must have been 20,000 people just north of town. Every first place we went to, two places, there were just cars lined up everywhere. We ended up going down this dirt road, and then the cars are lined up there, and went down another smaller dirt road and ended up in the middle. And there are still cars there. There are cars everywhere watching the Northern Lights that night, which is really interesting. So this is a picture that we took that night. But if you have one of these predictors things, there's something called the KP index. You watch that. It's a number usually between 0 and 5, and you want to know where that is. And based on that, you're going to say, what, are you likely to see Northern Lights? Is it possible to see some Northern Lights, or is it just not likely to see Northern Lights? So those are these three things. Again, there's different options here. Common one is just a menu here. So Pizza Luce is, a small chain. They have places down in the Twin Cities and in Duluth here. And so this is some things off the menu. So you just display their menu and ask the user what they want to order. And then you say, okay, you want to order that. So you ask the user to enter a number 1 through 5, and then you'll print out what they order here. So if they order 2, you want to print off chicken parmesan. Yeah. So for that. I'm gonna do this one, I think. This is just breast cancer detection. In machine learning, we actually train models that do a more complicated version of this. But I guess I'm gonna maybe try this one out here. It asks for 2 things: a tumor radius, a tumor concavity. So again, usually when you're doing breast cancer scan, a tech will measure these things based on that scan. And then based on those measurements, we can try to predict if it's malignant or benign here, if it's cancerous or not, basically. So we can do that. So again, you can try those out. So maybe I'll again, just pick one of these you want to try out and do them. I think I'll do this one. So I'm just going to run NetBeans. So one of the things to watch when you're doing this is, to work on your debugging skills and coding skills, see if you can find the errors here. So again, sometimes it'll just be, errors, syntax errors where you're typing in something and, it won't be right here. And again, you can sometimes look at this, and sometimes the little hints will be okay. But this one is saying import Java time clock system. That's not what we want to do. The problem here is actually system is uppercase. So sometimes I just like to look at other examples of code I've done and see what I've done there and compare that to the error. And then sometimes that'll help me spot it. Sometimes you can ask AI about it, or again, ask a friend, a neighbor, or call me over, ask me about it to figure it out. The harder errors sometimes to find are the logical errors. So here I think I did this right. If the radius is greater than 15, it's malignant. If the cavity is greater than 12, or 0.12, it's malignant. Otherwise, it's benign. And so I did that. If the tumor radius is greater than 14, I said it's malignant. If tumor radius is greater than 12, I said it's malignant. Else, I said it was benign. I run an example here. Tumor radius of 10. The tumor concavity is 0.1. It says it's malignant, not cancerous. That's good. But I don't have my if-then structured correctly. So then I should try out some other things. So if I enter a big size tumor here and like a small concavity, it's going to say both the tumor is malignant and the tumor is benign, because I don't have my else ifs set up. I have actually this if, and they're separated here. A couple things you can try when you're trying to find these errors. Again, one thing I says you can ask AI. So sometimes I just like to, when I get done, I think I have a solution. I just ask AI to do the same thing. So I just paste the problem in. I just copied this and pasted it in here and said, write a simple program to do this. And it does. And I can kind of then compare how my program looks compared to this one. So again, they do an scanner input, new scanner, and I have that. They enter the tumor radius, and they actually say between 0.1 and 2.5 here. And that's nice. And so they read that in and call it radius. I just said enter the tumor radius and read it into something called tumor radius. So that's similar. And they're using next double tumor concavity. They specify the range, and they do double that concavity, next double. And then they do this sort of range check. They make sure the range is in the right area for that. I'm not too worried about that. So I wasn't required to do that. So again, ChatGPT sometimes will do extra stuff. So I'm just going to skip that here. And here they do a more complicated. If the radius is greater than 15 or the concavity is greater than 12, then they print this out here. One way of doing it, maybe not the way I would do it. I would do it this way here. Another thing you can do is you can take your code and ask an AI to help with that. So I could say, help me fix the error in this code where it sometimes says a tumor is both types. And I'm just gonna paste my code in there and see what it does for that. On most of these examples, there's also going to be a bonus challenge or two that you can try. And sometimes there'll be a sample solution here. Sometimes I'll record a video that walks you through some of this, so you can see that if you want. So like here, and usually it's often the bonus challenge is just something you might have to look up or do it. Like here, we want to add a condition if the radius is greater than 12.2 and the concavity is greater than 8.5. That's actually not something we'll get to with this and until next week. But again, it's a good challenge. You can maybe see if you can figure out how to do that here, even though we haven't really covered that part. Other places like I might introduce like here, the bonus challenges do generate a random number. We haven't talked too much about or at all really about random numbers right now, but here's how we generate a random number here. And you can put that in your program too. So there'll be different challenges here for this. But I want to take some time and just talk about the assignment then this week. So I'm going to go back here to the unit. And talk about the assignment here. So for the assignment, you're going to modify a program that's out there. So you have to download or get this Book Lookup program. You can download the zip file and then unzip it and then open it up in NetBeans, or we can go here and grab it from GitHub here. I'm just going to grab it from GitHub because I think it's a little faster for me to do that. So again, I'm going to go to team, git, clone. I'm going to paste in the project name here, and I'm just going to hit finish, and it should open the project up. I've got so many projects open here. So it should be called Book Lookup. So I'm going to look for a project called Book Lookup. I'm going to find inside source packages the Book Lookup Java file and modify that. And there's a beginning Java file already here. And the main program's here. And then there's a line here. It says, don't modify anything below this line. There's some additional stuff, files here, which are a little more complicated and stuff for you to do. So I'm just going to run this so we can get an idea. What does this Book Lookup do? It says, welcome to the Book Lookup. Each book has a book number and ISBN that uniquely identifies the book. ISBNs are either 10 digits like this or 13 digits like this. Enter the ISBN number of a book you'd like to get information of. And if it's like this format, don't enter the dashes, just the digit. So if I want to take this one, I'm just going to enter that. I'm going to be lazy and just type it in there. I mean, just cut and paste. And it'll look it up online and tell me what the title is and the date it was published here. It uses just so you know on the back end, a web service called Open Library. And it actually goes to a website like this. And the website gives us this data back, and the data is in a format called JSON here. And inside this is the title and the weight and the number of pages and the date it was published here for this. So all that stuff is in this. And then we have to pull this out. So there's some code in here that goes out and retrieves the data in this what's called JSON format, and then it parses this data and searches through it and finds certain characters in here, finds where the published date is, and extracts the date out there. So that code's already here. You don't have to do any of that. It's more complicated than you know how to do quite yet. Instead, you have to go up here and in the main program, do some changes here. So what do I have to do? Run the program, it allows you to look up an ISBN number. Yep, we got that. While the program works, it does not have any error checking functionality. So if the user enters an invalid ISBN, you want to provide that. So if I run this again and I just enter a number like 555, it's going to try to look 555 up, and 555 isn't a legal ISBN number. So it's going to have some trouble with that. It's going to say the title's not found. We don't even want to search for that title if it's not 10 characters there. So we want to make sure the user enters an ISBN number. If it's less than 10 characters, we want it's too short, and then we won't look up that. If it's too long, more than 13 characters here, then we're going to say, or then it's too long, and then again, we're going to not search. So if the user enters an ISBN that doesn't satisfy any of these conditions, you do not output the title or the date of the book here. Otherwise, you can proceed as normal here. So basically, we want to read in the ISBN, and then we only want to do this stuff if the ISBN has 10 digits or more. And we don't want to do it if the ISBN is more than 13 digits. So we want to see how long, how big this ISBN, make sure it's the right place. And we only want to do this stuff. Only want to look up the title and print out the results if the ISBN is the right size. So you're going to have to write some if-then statements to check that out here. So that is your job, is to figure out how to put some if-then statements in here to do that. So, and once you're done, you can zip up this project and upload the zip file for this and set that up here. Questions on this assignment? So the rest of the class, feel free to work either on some of the review problems or get a jump start on this assignment and see if you want to work on that. Either one is fine for that. Okay.